Before we go deeper into the concept of impedance, let's first review a little bit about AC voltage and AC current. We said impedance is the ratio between AC voltage to AC current. AC voltage or AC current are often, as what we learned before in physics, sinusoidal. Sinusoidal. Here we plotted, for example, voltage in blue and the current in brown versus time. Okay, for AC voltage in blue and AC current, for example, in this dotted brown line. And as what we learned before, AC voltage can often be written as V total AC voltage is V0 cosine omega t. V0 times cosine omega t. V0, as what we learned before, would be AC voltage amplitude. 0 for amplitude. It is the magnitude for this oscillation, this voltage oscillation. Omega would be the radio frequency. Radio frequency. In geometry, we say angular velocity, but here we would call it radio frequency. And it's in the unit of radian per second. Radian per second. Okay? T, of course, would be time. And if we define F as frequency in the unit of hertz, then the radio frequency and the frequency would satisfy this relationship. Omega, radio frequency, sometimes we call it angular velocity, but here for AC voltage, radio frequency would be 2 pi times frequency, which is frequency has unit of hertz. Okay, so this is the relationship that we quite often use to describe an AC voltage, V0 cosine omega t. Sometimes, of course, you can use sine, but convention, we quite often write it as cosine omega t. Okay, and t is 0, it reaches maximum, and this is a one period, a second period. And this brown dotted line is for AC current. AC current. It has magnitude, and also let's say we write it still as cosine and omega t, but shifted by an angle of phi, cosine. Okay, so these are examples of AC voltage in blue and the resulting AC current in this brown dotted line for AC signal, electrical signal.